Okay, thank you, Bill. Thank you, Jay. And I'd like to talk about the popular topics of dark matter and dark energy and some other physics. So what's happened over the last half century or so is that people have put together something called the Standard Model. It deals with electrons and quarks and Higgs bosons and other things you've heard of, a lot of the physics that we know. However, we've also discovered in the same time that the Standard Model stuff that we're familiar with isn't a very big portion of the universe. There's 5 times as much, roughly, dark matter as Standard Model stuff, and 13 or more times as much dark energy. So the question is, what are these other two things? In fact, observation and experiment do not get us a lot of knowledge, and the conjectures that I've been able to find from other people actually are very vague. So what I'd like to share with you tonight is probably the best defined conjecture as to what dark matter and dark energy are, and hopefully it's even good physics. So there's a lot of math behind this. I'm not going to talk about that, but it does go back and it gives the possibility that Standard Model physics is actually more useful than people think. And in fact, there might be 24 what I call ensembles or uses of the Standard Model. One of this is what we know. 5 of them are dark matter. 18 of them are dark energy. And they have a reciprocal relationship with each other. So what's going on here is that the ensembles do not share light. They don't see each other. We don't see dark matter. It doesn't see us. But we do share gravity at least a little bit better. We share gravity with 6 ensembles, as does every other ensemble. In our case, it's us plus what we consider to be dark matter. Now, this is already a breakthrough because I've unified electromagnetism and gravity, which is an age-old problem in quantum mechanics and physics. But it goes on. It turns out there are probably some forces that connect groups of 12 and another set of forces that connect groups of 24. So we wind up with a very interesting picture here of the universe and some very simple math that comes out of 6 times 2 times 2 is 24, but the underlying math actually has another factor of 2, and the question is, what is the other 24 if they exist? And what I see going on here is very simply, there are probably 48 ensembles. Unfortunately, or whatever you want to say, there are no forces that connect our 24 with the other 24, so there's no communication possible. Now, out of these, any one of them, since it's like us, could have physics-savvy beings, and they might be, if they're the same evolution that we are, asking the same sort of questions we do. So I'd like to share with you a few of the challenges that we have in physics, and then come back to some other ideas. One of them is the quantum gravity, integrate electromagnetism and gravity sort of thing. I think I've done that by actually embedding it in a bigger problem and doing the whole thing there. You may have heard of neutrinos. One of the mysteries today is what are the masses of neutrinos? I've got some candidate masses. I have some ideas about some symmetry violations. I have a list that has a few more elementary particles than does the Standard Model. And we have some possible application in terms of atomic nuclei, which I'll come back to in a bit. Philosophically, there's some interesting things that come out of this. I think on a very small scale, there's faster than light phenomenon. And compared to what physicists talk about as the smallest sorts of things, I think I've shrunk that considerably. But we won't have time to do details. As far as the research, it does suggest ideas for more research, suggests some math that can be reused, encourage us to rethink, as we already have, 24 versus 48, what's the universe, and a little bit about space-time. As far as practical applications, if the nuclear physics area is pursued, maybe we'll have a better handle on the ability to make new elements or not. And in general, throughout all of this, there are new phenomena to measure and maybe someday to actually do something with. So to come back a little bit, 24 ensembles with reciprocal relations. What we consider to be dark matter would consider us to be dark matter. What we consider to be dark energy would consider us to be dark energy. Very possibly there could be beings in any of these ensembles. So very possibly we are some other being's dark matter, and we are yet some other being's dark energy. So we've fulfilled the mission tonight. Look around you, see what you see. You are looking at somebody's dark matter, and you are looking at somebody's dark energy.